This week we will discuss about the AC circuit analysis. Comparatively to the other topics, this one is a bit hard, so you have to pay attention, okay? Because here we are learning when we have sinusoidal voltage or a current AC, it's changing with the time. So we have to use complex numbers, and also we have to use trigonometry to answer these questions, okay, solve these questions. So please pay attention, otherwise, like, this, you get one question from this one in your final exams. Oh, I can't remember that, but you have, I can't remember that. So it's an important topic, and also it's a bit harder than the other topics that we have done so far. Okay. So do you know the difference between the DC and the AC? So far we have discussed about the DC, am I right? We have discussed about the AC a little bit when we were doing the diodes. Apart from that, we always dealt with AC. DC. So this is here we are going to learn about AC, as I have mentioned. So what's the difference between the AC and the DC? DC means what? No, DC. What is the meaning of DC? Direct current. So that is not changing with the time. The direction or the magnitude of the current and the voltage is not changing with the time. So you can see a graph here. Do you see the graph? So you can see this voltage is not changing with the time. But AC means either the magnitude or the direction. If they are changing with the time, we call it AC. So here, this one is AC, and also how about this? If you have a voltage like this, is it a, can we define this as DC? Why no? Maybe its magnitude is the same, but it is changing the direction. Do you see that? Positive and negative. So either magnitude or the direction. If it is changing with the time, we call it AC. So we are, what is the current coming out from the wall socket in Australia? Not only in Australia, all the countries. So what do we get in? AC or DC? What's that? AC. So some of the equipments are not working with the AC, so that we have to convert AC to DC, and we talk about those stuff before when we do diodes and rectification and all that. Am I right? Yes. Okay. So we need to remember here. So AC current is changing the direction as well. So you can see this is in the positive direction, so maybe going this way. When the negative half happens, it is going in the opposite direction. So it is changing the direction and also changing the magnitude. If you see here, it is a sinusoidal graph. So we have in Australia, we have 50 hertz. That means this cycle is changing. There are 50 cycles per second. So that we call the frequency. Frequency is the number of cycles per second. And the period is time per cycle. So 1 over the F, or 1 over 50 will be the period. 1 time per cycle. There are, when we consider the sinusoidal signal, we need to know how tall the signal is. That will give you the amplitude. So you have done this in physics as well. And also we need to know how fast it is happening, going back and forth. So that we call the frequency or the period. So how fast, how many cycles per second. And also we need to know how much degree it has been shifted in the x-axis. So this one is not shifted at all. So it is starting, like, when we define it, it is at comparatively. For example, if you consider this one, it is starting from 0, and we can have another signal going like this. So it is shifted towards the right. And also there can be another signal going like this. It is shifted towards the left. So that we call the shift, or else we call it phase angle, or we will discuss it later. So we need to know that as well, how much it is shifted compared to another one. So for example, voltage compared to the current, or current compared to the voltage. So we need to know that. So we call that the phase. It can be positive or negative depending on whether it is shifted towards the right or left. We will learn more about it later on. And we need to know the angular velocity, which is omega. I hope you are familiar with these words from physics. So that is 2 phi f, or else angular velocity is time, angle divided by the time. So for example, one cycle is 2 pi 360 degrees. Am I right? 2 phi divided by time per cycle, we call that the period. So 2 pi over t will be our angular velocity, or else if we replace the t by f, that will be using this one, that will be 2 phi f. So that is our angular velocity. Make sense? We are going to use this in our questions, okay? And also we need to know wavelength. Wavelength, we use the lambda for the wavelength, and omega for the angular velocity. Lambda is the length of one cycle, so that will be lambda. And if you know the speed of the cycle, speed times the t is your lambda. You know that, right? From your physics, do you know that? Okay, that's good. Okay, now let's see phase angle. That is something important for us. So phase angle, if you look at the phase angle, you can see there are two signals here. One is the voltage signal and the other one is the current signal. So you can see current is shifted. If you consider this x-axis as the omega t, or else theta, and y-axis can be either the voltage or the current. So you can see voltage is starting at 0 and it is following a sinusoidal cycle. And if you look at the current is shifted. So you can see this one is starting 0 and this one is starting after, like, it is shifted towards the right. Am I right? When it is shifted towards the right, it has a negative phase angle. If it is shifted towards the left, it has a positive phase angle. So if voltage is Vm sine omega t, the current signal is as it is shifted towards the right, it is omega t. So this will be becoming omega t minus theta or minus 5, because this is shifted. It is not starting at the same time. Make sense or not? So here, whatever you have in front of the sine cycle, this we call the amplitude. Amplitude means what? The maximum point of that curve, isn't it? And here the current amplitude is I max, and this is the, like, whatever you have in front of t is your omega, which is your angular velocity. And you can have a phase. If you have a negative phase, that cycle is shifted towards the right, and if you have a positive phase, it is shifted towards the left compared to the other cycle. Make sense or not? Are we good? Okay. So you can see these ones. Okay, so normally when we are dealing with the AC signals, we always use cosine signals. Cosine, we convert, if there is a sinusoidal one, this we are converting it to cosine, because when we have to explain a cycle in the time domain, that means as a function of t, we are using cosine. In case if we have a sine signal, from the trigonometric relationships, we can convert it to a cosine. Am I right? So whatever you have in front of the cosine signal is your amplitude. It can be either if it is a voltage signal, it can be the voltage, maximum voltage, or else if it is a current signal, whatever you have in front of the cosine will be your current amplitude. And whatever you have in front of the t will be your angular velocity, and this will be your phase. Okay, so these trigonometric relationships are very important for you. you need to know how to convert them from, like, you know, everything. You need to know how to convert to cosine. Okay, so can I give you a few minutes from your physics knowledge? You can do these questions. Given the sinusoidal signal, so they have given you sinusoidal signal this. Calculate the amplitude, phase, angular frequency, and the period, and the f. So what are the things you need to find? Amplitude, you need to find the phase, you need to find the angular frequency, which is omega, period t, and the frequency. Okay, I'll give you a few minutes for you to try. First thing is converting this to cosine. So how do you convert 5 sine to cosine? So you have few, I have squared the ones that you may need. So sine to cosine, how do you convert it? How about this? Don't make negative in front of the cos as well, okay? Try to make it to a positive. So if you use this one, what it says, sine alpha is equals to cos 90 minus alpha. Am I right? Can we say like this? So using this one, can you please convert this this signal to a cosine signal? Am I right or wrong? I just took this. You can use the one that you mentioned me, but it makes a negative sign at the front, isn't it? So we try to make it to a positive, always have something positive in front of the cos. So how do you convert it? You get the formula sheet, yes. This one you get, but nothing else. For maths, you get this, or you have to remember this. You get this. Okay. In my time, we have to remember all that. Yes. Now, no, it is a long time ago, but I was. So if I convert this, that will be, what is your alpha? Alpha in this case is whole of this, right? That is 4 pi t minus 60 is your alpha. Do you agree or not? Okay, so how do you convert it to cosine? 5 cos 90, pi over 2 means 90, am I right? And minus, okay, so here, cos minus is cos, isn't it? Yes, yes. So 90 minus 4 pi t minus 60. Am I right? Is this right? If what's that? T over 2 for what?
Can we like sub 4 pi t into pi? Yeah, so that we cancel out the number 2. Yeah, we have 2.256.
So are you saying this?
Not minus. Over 2. The 4 pi t over 2, then minus the 60.
Okay, let me do in this way, 90, 150. I have this, and then we can say 5 cos minus, I take the minus sign out, 4 pi t minus 150. Then this, we can use this one. Cos minus is the same thing, so I can say 5 cos 4 pi t plus 150. Is that what you are saying? you don't have to, but like you can't add 2 pi over 2 and 4 pi because they are not like terms. Are they like terms? Because here you have t, but you don't have a t here. How do you add them together? You only can add 90 and you can add or minus 90 and 60, but you can't do anything with they are not like terms. 4 pi t, there is a t, it's like a x. If you have 4 pi x, can you add like you only can add like terms, isn't it? You can't add 2x and a 2. You can't say it is 4. Can you? No, they have to be like terms. So this is what I got. Does that make sense? No? Okay, so let me explain again. So you are saying that why can't you add pi over 2 and 4 pi t together? Then what you're asking? Yes. Your alpha, this is right. So you have this. So alpha is what? Your alpha is this part. Am I right? So you have to put, instead of alpha, you need to put this part. Am I right? Isn't it? You have to. Oh, okay. Make sense? Okay, now if you have done that, I want you to say, tell me the amplitude. What is? Do you need time? Do you need time to convert sine to cos? When you finish, let me know. Then we'll discuss about finding the amplitude, phase, omega, t, and f. So when you finish, let me know. Okay. Okay. So what is the amplitude? Amplitude is 5. So do you all agree with that? Amplitude is 5. So what is the phase? Phi is what? That phi is what? You need to mention what is it? Okay, so what is it? Sorry, I have to put negative here. Am I right? This should be negative, isn't it? Yes. So what is the phi? It's negative 150 degrees. Whatever you have here will be your phase. Negative means what? It has shifted towards which direction? No, I am asking whether it is shifted towards the left or right. I explained you in the previous slide. Towards the left or towards the right? Towards the... Did you write it down or not? Did you write it down when I was telling that? So when you have like this, there is no phase. And I told something can shifted towards this way. So when it is shifted this way, whether it is, what is it? Something also can shifted this way. Is there anyone who written down this negative phi and positive phi? Did you do that? Did you do that or not? Okay, so I'm not going to tell you. You have to figure it out when we were doing the next questions. Okay, so phi you need to explain it as a negative. Tell it as with the positive or negative. Okay, so this is a negative 150. You have to tell me whether it is going towards the left or right. When we were doing the other questions, I may say it again. Otherwise, you guys need to find it out. Okay, all right. That's your punishment. And what is the omega? Omega is whatever you have in front of t. So what do you have in front of t? 4 pi. And t is what? How do we find the period? Period is what? So omega is what? Omega is 2 pi over t. Omega is theta divided by the time. So theta of one cycle is 2 pi, 360 degrees divided by the t. So you can rearrange this. You can rearrange this one and find me the t. What is the t? Omega, you know, you found it. Omega was what? 4 pi. So if you rearrange it, you have this as half. Am I right? So t is half a second. Am I right? So this is half a second and frequency is 1 over the t. So that will be 2 hertz. Hertz are per second. So you can find all of these stuff. Are we good? Okay, so if you have finished it, you can do the example 9.2, this one, and I'll give you time. Okay, yes. So you do this. Find the phase angle between. So you need to find the phase angle between these two. So to compare two signals, both need to be in either cosine or sine. So make one is already in the cosine. So I1 is in sine. So you have to first convert the I1 to cosine. Yeah, I'll give you time. You do it, and then after you try by yourself, I will do that. Okay, so how did you convert this? So you have I1 you need to convert, that is negative 4 sine 377t plus 25 degrees. Okay, so you need to you have to get rid of this one, and also you need to get rid of the sine. Okay, negative and also the sine, and make it to a cosine. So what did you do? You can use this, am I right? Are you going to use this? So that will be your alpha will be this part. Am I right? So this negative will be cancelled out. So that negative is not there in this quadrant, isn't it? So you can say this is equals to cos 4 cos 90 plus alpha. Am I right? So 90 plus 377t plus 25. Agree or not? So minus is not there anymore because we have selected this one. So how we can sort it out? 4 cos 377t plus what? 115, isn't it? Am I right? So this one has 115 positive and this one has 40 negative. Now you're comparing the phase angle. They are asking you to do the phase angle. So now what can you say about this? What is the phase difference? If you consider the phase difference is 115 minus 40, that will be, isn't it? So phase difference will be 155 degrees. Am I right? So when you plot it, how do you plot it? How do you plot it? Okay, I'm going to show you this again. So now you have to pay attention. Okay, write it down because you need this. So when you have no phase means what? You are starting at 0. It's like this. Am I right? So when it is shifted towards the right, so this one is starting here instead of starting here. So it was shifted towards the left. This one is shifted towards the right. So when it is shifted towards the right, it is a negative phase. So negative phase is shifted towards the right And positive phase is when it is shifted towards the left. So you need to remember this. So how do we say leading, and I didn't tell you about the leading and lagging. That's why I came back to here. I've forgotten that. So here, they both are not leading. There is no phase difference. So when a current is going through a resistor, this is what's happening. Okay, so there is no phase difference. So they are in the same, like, starting, and both the starting, like, going at the same without a phase. So this one, what can you say about this one? Voltage is at here. Current is shifted towards the right. So current has a negative phase. Agree? And what can we say about the leading and lagging? Current is lagging the voltage. When you have current is starting late, can you understand in that way? So when you have a negative phase means lagging. So that is compared to another one. Okay, so current is, so I can say I is lagging the voltage, or else we can say in the opposite direction, we can say voltage is leading the current. Voltage is happening earlier, isn't it? So we can say voltage is leading the current, or else current is lagging the voltage. Makes sense? And here what can you say? Current is leading the voltage. So why is that? Phase is current is starting, current has shifted towards the left. So that is a positive phase. We can explain it in different ways, but if you remember this way, I think it is easier for you to remember. Otherwise, sometimes we consider this one here, or else this one here across the y-axis. But I think the way that I am explaining is more easier for you to understand. Okay, so when it is shifted towards the left, the current is shifted towards the left. So that current is leading the voltage, or else we can say voltage is lagging the current. Makes sense? Are we good? So you don't have to, next time when I ask, you have to tell me the answer, okay? That's good. We are going to use this trigonometric relationships, and I will be giving you this formula sheet for your exam, for you to go through this. No. You even couldn't remember that phase lagging and leading, the shifting. So I don't expect you to remember this whole thing. Okay, just remember that one, okay?
We only need to use the one in the box, right?
Yes. Mostly sine to cosine, cosine to sine. Yes, sometimes we need this as well, because when we have a negative, we need to make it to positive. That's it. Okay, now we are moving to complex numbers. We need complex numbers for this one. We are going to learn about resistors, capacitors, and inductors, leading and lagging. So we have to sometimes convert a signal in the time domain to polar domain to in different ways, like, we have to convert it to different forms to do the calculations. Okay, now let's see complex numbers. What do we mean by complex numbers? Complex numbers are represented like this. Am I right? A number, for example, 5 plus 4. I'm not going to use I, because we are using I for the current. So to make it different, we are using J for the imaginary part. What do we mean by this? What is this? 5? 5 is the real number, and 4 is the complex number, isn't it? So what is this J? J means what? Yes, what is it? So that will be the square root of -1. Whereas J squared is -1. Am I right? Is that right? So how do we plot it? In your XY axes, when you are plotting a complex number, your x-axis is the real axis and the y-axis is the imaginary axis. So along the real axis, you have to go 5 in this case, and along the imaginary axis, you have to go 4. Along the real axis 5, along the imaginary axis, you have to go 4. So after we plot it, we can, this number here, for example, this 3 is your real part and 4 is your imaginary part. So you can find out the angle making with this point here, the angle making with the x-axis or the real axis. So what is that angle? This theta is equals to what? Tan inverse opposite, which is your real, imaginary part, which is 4 divided by 3. Agree? Is that right? Tan is opposite over the adjacent. So opposite is your imaginary part and the adjacent is your real part. So 4 over 3 in this example, isn't it? And also you can find the length of this line. How do we find the length of that line? That will be, it's a triangle, right angle triangle. If you use the Pythagoras theorem, this one here, R, is equals to 3 squared plus 4 squared square root of it. Do you agree or not? Okay, so we can convert this complex number. We can convert this complex number to polar form. Polar form means with the, have you done the thin maths? Okay, so that will be, R will be equals to 3 squared plus 4 squared square root of it, and theta is equals to tan inverse 4 over 3. So we can convert this to this. So this we call the rectangular form, or else the complex as a complex number, and we can convert it to a polar form just by doing this, isn't it? We may not need this one, so don't worry about it. Are we good? And when we have this in the polar form, if you have this in the polar form, this R is your amplitude. Okay, so you can convert the polar form to, time domain as a cosine signal. So in that case, your cos omega t plus theta, and this will be your R. So this, after you convert a complex number to polar form, you can convert it to a cosine signal, which is your R will be your amplitude and your phase will be your this theta, which is coming here. So omega, we have to use another method to find it, or else it should be given to us. So apart from the omega, you can convert the polar form to a cosine signal. Make sense? So complex number to polar form to a cosine signal. So we need to convert them, like rectangular to cosine, cosine to rectangular. So are we all good with that? Are we okay with that? All right. So I'm going to, okay, the other way around. If, let me check. We have some questions. So we'll do the questions. Okay, so this one, how can you convert to polar form? And then I want to convert it to the time domain. I'll give you time. Don't look at this, okay? Do it and let me know when you finish. I want you to convert this to polar and then to a cosine signal. So go from the basics. So first, how do we plot this? This will be 5 and this will be 6. Agree? Agree? Okay. So we need to find this theta. So tan inverse, what is it? 6 divided by 5. Agree? What did you get? 6. No, this is 6. And this is 5. 50 degrees. Okay, so let's take 50 degrees. Okay. And then what will be your R? 6 squared plus 5 squared square root of it. What was that? Okay. What is it? 7.8. Do we all get that? Okay, so how do we convert it to the cosine signal? That will be 7.8 cos omega we don't know, but we have a positive 50. Agree? Agree? So this is positive because, like, whenever you measure the angle towards the counterclockwise direction, your angle is positive. Okay, so when you are measuring Counterclockwise direction, positive angle. In case if you are measuring the clockwise direction, your sign will be negative here. Do you understand what I mean? Okay, so you need to remember that as well. Whenever you are measuring from this positive real axis towards the counterclockwise direction, you have a positive sign here. When you are measuring towards the clockwise direction, this will be a negative signal. Make sense? Are we good? Okay, so let's move on to the next question. Any question? Okay, so we need to know, we are going to work with complex numbers now. So we need to know how to add them, how to subtract them, multiply them, and divide them. Okay, so when we do addition and subtraction, it is easy to keep the complex number in the rectangular form. That means 3 plus 2j, kind of like, you know, in that arrangement. But if you do multiplication and division, it is easier to do multiplication and division in the polar form. So addition and subtraction is better in the rectangular form, and this one is easier in the polar form. So whenever we have in the rectangular form, we can convert it to the polar form to do the multiplication and division, and whenever we have it in the polar form to add and subtract, we can convert it to the rectangular form. So if I show you, so I hope you remember what you have done in your maths for adding complex numbers. So when you are adding complex numbers, how do you add them? You add the real parts together. Am I right? You add the real parts together and you add the imaginary parts together. And subtraction also the same. So you subtract the real parts and you subtract the imaginary parts separately. Am I right? And how about the multiplication and division? I told you, you can do it easily in polar form. So when you have in the polar form, you can multiply this R values and you can add the angles together. In the polar form, that's how we can multiply. When you do division, you can divide this R's and you can minus the angle. So we are going to do some questions, then you will be okay. Okay, let's do some questions. For the questions, we will see, I already told you this. Whenever you have this will be your this part, and whatever you have here will be your this part. So I already told you this one. Okay. I told you this one as well. We will do questions. Be fine. Okay. Now can you do this? I'll give you time and I will do it after you try. Convert the following signals to polar form, then to the rectangular form. So you have it in the cosine form, and I want you to do it in the let's do this one. Okay, when you finish with this, yeah, do this one. Okay, so what can you say about this? How do you plot this? So if you convert this to polar form, how do you convert it? That will be 6 and a negative 40. Do you agree? Negative 40. Okay, now how do you plot this? Negative means what? Going this way. Minus 40. So this is 40 degrees. Am I right? So what is this length here? 6. So what will be your component in the x direction? So that will be 6 cos 40 and this will be 6 sin 40. Agree or not? So you can write cos 40, that will be what? 6 . How do you write the cos 40? Cos means what? Yes, so this cos means cos 40 means adjacent divided by the hypotenuse. So a adjacent here is the real axis. Am I right? So you can say adjacent, which is your real part, will be 6 cos 40. Agree? So how do you write the sine? Sine is opposite over the hypotenuse, which is equals to, so that opposite, which is your imaginary part, opposite which is your imaginary part, will be 6 sine 40. So you can't go wrong here because you have already done this, I think. So how do you write it in the rectangular form now? So your rectangular form is something plus something times j, isn't it? So this is your real part and this is your imaginary part. Agree? So what is your real part now? 6 cos 40. Am I right? And your imaginary part is negative, because why? It is going in the negative side of the imaginary part, isn't it? It's a negative 6 sine 40. Agree or not? So how do you write it? So you can write it now in the rectangular form. You can write it 6 cos 40 minus 6 sine 40j. So you can put this in the calculator and you can find the number. What is 6 cos 40? 4.6 minus 6 sine 40? 3.9j. So we have converted the cosine form into polar form first, and then we converted it to the rectangular form. Are we good? So to convert from time domain to rectangular form, you need to have this signal in cosine first. Okay, so you can do it only when it is in cosine. So if you have it in sine, what you need to do, you first need to convert it to the cosine. Okay, so if you have finished with the first part, you can do the VT now. Convert that one to again to polar form first, then to convert it to the rectangular form. I'll give you time again. If you have any question, you can ask.
Rectangular form, it's going to be rectangular form equals to that, or
this is the rectangular form. This is your rectangular form.
We just leave it like that.
Yes. So this will be your rectangular form. This is your time domain, signal in the time domain, and polar form. Do you remember the polar form? What was that polar form one? That was 6 and a negative 40. So 6 and like this, negative 40. So this we call the polar form. So this is polar form, rectangular form, and the time domain. Make sense?
Just leave it like that.
Yes, you'll just leave it like that. Yes.
So like a simple test in the final exam, just write like that.
No, in the final exam you don't get questions like this. You get circuits with capacitors and inductors. You need this knowledge to solve this one. Just this is just the foundation. Reminding you the things that you have done in maths. We haven't come to the electrical part yet. Okay.
Why sound so difficult? It's super difficult.
Okay. You have to do the second part. Okay, VT. I'll give you time. Okay, so how do we do this? You first need to check this, and you need to negative sign. So what we need to do it? We have to use this one here. Am I right? So when you convert it to cosine, that will be what? 4 cos 90 plus, isn't it? So 30t plus 140. Okay, that's good. So how do you convert it to polar form? 4 and 140 degrees. Positive, isn't it? So when you draw it, how do you draw it? Counterclockwise direction, because it's a positive angle, and that will be here. Am I right? So am I right? 140 means what? 140, 90, 50, and this will be, how is this theta? What is that? 180 minus 140, which is 40 degrees. Agree? Okay, so that one is 40 degrees. So now how do we find the components in the real axis and the imaginary axis? That theta is, that will be 4 cos theta will be your real part. It is a negative value. Agree? So this will be, this is 4. So this part will be 4 cos 40 and this will be 4 sin 40. So when you write it, you have to write this is as a negative one. So you can write it as negative cos, 4 cos 40 plus 4 sin 40j. Am I right? What's that? 40 because like this I was looking at this angle 40. Yes, otherwise you can use the 140 and you can ignore everything, like without plotting you can do it. You can say you can, I think this is more practical. If you do plot it and do it, then you know what is happening. Otherwise you can just say real part is cos 140 and imaginary part is sin 140. Still you get the answer, but you don't have to think about negative and positive in that case. But if you plot it, you can, it is more practical. I think you know what is happening. You see it in front of your eyes. Are we good? But whatever the way that you do, you still should get the same answer. We can't get two different answers for this one. So what do you get? Either way you have to get, if you have done 140 using 140, that should be fine. But let's see whether we get the same answer. So what do we get? Negative 3.1 plus 2.6j. So when you use 140, do you get the same answer? Okay, that's good. Okay, so are we good? Can I move to the next part? I'm moving to the next part, okay? Any question? Okay, can you convert this to time domain, please? As a cosine signal, that means time domain means with t. So make it to cosine. No, we haven't. We don't have a signal circuit set. No, we have circuits. You guys get circuits. This is just the basic foundation. You already have done this, but you have forgotten. So that's why we have to refresh. Yes, so if the frequency is given to you, you can find the omega, but otherwise you just make it as omega. Just leave omega t. In front of t, just put omega. In case if the frequency is given to you, you can find omega. What is omega? Omega is equals to 2 phi frequency. So you can find it. Frequency is normally given to you in other questions. So you just use omega for this one. Okay, let me see what we get for the first one. Do you get this for the first one?
Yes.
Where did you go wrong? Yes, we do the same. So you found the angle. Did you find the angle? So why the other side? So you need the component. So you found the angle 53. So you now find the components, x component and the y component. Isn't it? You did in the previous one, we had to find the other angle because it was in the other quadrant. Isn't it? This one is not that complex. You have it in the first quadrant. So did you all get this?
Yes.
Okay, that's good. So now the second one, when you finish, let me know, okay? Okay, now the second one. Second one is somewhere here, right? When you plot it, it is there. Okay, so how do Okay, the second one, how did you do that? So your x component will be what? 3 squared plus 4 squared, square root of it is your, what did you get for this? 5. So that will be 5. X component, or the real part, will be a negative 5. What is the angle? This one is 53, isn't it? So that will be cos 53 point something, and plus 5 sine 53. So what did you get for this? So not the real, this is your sorry, that's not what we need to do. No, sorry. So your angle is, what is your angle? It should be 180 minus 53 degrees. What did you get? 127, right? Yes, 127, and your R is this. So you can say 5 and 127, or else you can say here 5 cos omega t plus 127 degrees. If you want to measure the angle this way around, you can do that as well. 180 plus 53, then it will be a negative angle. Do you understand what I mean? So if you want to do it, you can say this as well. Negative 180 plus 153, which is 233 degrees. Both the same. Make sense? Because one angle is measured in the counterclockwise direction and the other angle is measured in the clockwise direction. Both the same. Do you agree with that? Okay. Now let's move on to the next one. Okay, now only we are starting the electrical part. We have circuits with the resistors, capacitors, and inductors all together in AC condition. AC means alternating. Okay, so when you have all these three together, we should be able to add them, minus them, and do all the calculations, but they comes with complex numbers now. Okay, so we discussed a little bit about these things when we were doing inductors and capacitors. The voltage across the inductor is given, voltage across the resistor is given by this Ohm's law. We already know that. And voltage across an inductor is given by this, and the current across the capacitor is given by this. We have discussed it a little bit when we were doing the capacitors and inductors. So when we have resistors, capacitors, and inductors together, we can, so they all are like, we can convert these resistance, inductance, and capacitance to something called impedance. So impedance is measured in ohms, and it is the resistance is same as the, impedance of a resistor is the same as the resistance. So we use C for the impedance, so that is equals to R for resistors. When you consider the inductors, that will be J omega L. You can remember this, okay? You get the equations again. But you write it down somewhere because we are going to use this in our questions. Capacitors, it will be 1 over omega j omega c, or else we can convert this to, if you times the top and the bottom by j, you get j over j squared omega c. Am I right? Is that right? So j squared is a negative 1, isn't it? This is negative 1. Do you agree? So this will be negative 1 over omega c j. So you can use this one, is easier for you to use because j is at the numerator. So you can add easily. So you can either use this one or else use this one for capacitor. So we should know how to convert the capacitance to impedance and inductance to impedance. So that's we need to do in the next part. Are we good? Any question? Okay, so write down this if you, yeah, it's good to write it down. Just this part, that's enough. We got this using these relationships. You don't need to know how we got it. You only need to know for this syllabus. You only need to know how to use them. So it's you can just use the equations. When you finish, let me know. Done? Okay. Okay, so see. So how we can convert this? I'll give you a few minutes. Can you convert these to impedance? So 250, when you convert it to impedance, that will be just 250. Am I right? And how do you convert this to an impedance? J omega L. So J omega is what? Omega is this. Frequency is given to you as 60 Hertz. So what will be your omega? Omega is 2 pi times 60. When you put this in the calculator, you get something. What do you get? What's that? 377. Okay, so that is your omega. So here J omega will be 377. What is L? 650 millihenries. That is your inductance. 650 milli you need to convert it to henries. So 10 to the negative 3, isn't it? So when you put this in the calculator, don't put the J, you can keep the J. So 377 times 650 divided by 1000, what is that? 377 times 650 times 10 to the negative 3, or else you just divide by 1000. $24.5. So this will be 24.5 J. Make sense? Any question? Can you do the same for this one? So I told you this, you can make this to 1 over omega c j negative. So you use this one, it is easy. It's the same thing. I showed you how it came. So omega is 377 again. C is what? 1.5 microfarad. So 1.5 times 10 to the negative 6 farad. So you just put the numbers here and you get something here. What do you get? 1 over omega c. So that will be 1 over omega is 377. And this is 1.5. 10 to the 6, I'll take it to the top. So this is negative. So when you put this in the calculator, this times J will be your impedance of the capacitor. J is the complex J. No, we know. J is square root of -1. You know that it is, isn't it? You don't have to put it in the calculator. What is the imaginary I? I means what? Imaginary I means -1. -1 square root of -1. That is how we, isn't it? Yes. So J, keep the J. We are not going to do anything with the J. We will leave the J. What do you get? Minus 17. 68J. Do you all get this? Do you get this? Understand it? So this one is this and this one is this. All good? Okay, now see, we have converted everything to impedance and it is measured in ohms. So you have three impedances in series. Agree? So we have 250, 25.5J and minus 1768J. So all three are in series with each other. Now you can do all the additions and subtractions, anything, considering them like resistors. So when they are in series, you can add them together. When they are in parallel, you can take the 1 over value and add it like you do for the resistors. So when you convert everything to impedance, you can do all the calculations like you do for resistors. Are we good? Yes. 250. Yes. All three are ohms. Yes, impedance is measured in ohms. This is in ohms and this is in ohms as well. All are in ohms. So they have the same unit, so you can add them like considering whether they are in series or parallel. So if you add them together, you know, that's how we need to know how to add the complex numbers. And what do you get? When you add all these together, what do you get? So you need to add what? 250 plus 24.5J minus 1768J. So this is what you have. So when you add these together, you get 250 minus 43.5J. So you have a complex number, rectangular form. So can't we convert this to polar form? We can. Can't we convert this to time domain? We can. So we know after we get the complex number, we will be able to convert it to polar, and also we can convert it to time domain. So we can do anything with this with the knowledge that we have gained before. Am I right? Make sense? Okay, so that's good. So we are going to move to a question, or let's see what we have. Are we done with this? Can I move to the next slide? Okay, so here when you consider resistors is always like, you know, it's I told you before as well, current and the voltage is, they don't have any phase difference. But if you consider the inductors, you can see you have a positive 90, so you get a J. So it is omega L J. J means 90 degrees. So it is always with a 90 degrees, isn't it? Am I right? And this one is negative J. So it is a negative 90. So for example, here your current is voltage and the current both are in the real axis like this. Makes sense? So and when you consider the inductors, your current will be, so your voltage here, AC voltage is like, you know, in the real part, actually not real, and I'm just saying the phase difference. Okay, so that will be like this, and your current will be somewhere here. It has a 90-degree difference because you have a J part there. Make sense or not? When you consider the capacitor, the voltage, if the voltage is like that, your current will be like this way. If the voltage is, it's a 90-degree difference in both opposite ways. Make sense or not? We'll do a question, then I can explain you better. Which one? No, you don't get this part. It is just an understanding. I will show you when you do the question. You don't need to have a formula sheet. Okay, so let's do, I already explained you, when you have the impedances in series with each other, you can add them like this. When the impedances are in parallel, you can add them like this. Okay, so let's do this one. Okay, so can you convert all of these to impedance first? Too much? Yes, just try. If you need a break, I can give you 5 minutes break if you want to. Do you need a break? So first thing is for you to, if you were not here, I was telling, first thing is for you to do convert this all to impedances. So when you convert them to impedance, your capacitor will be something times negative J. So these are two capacitors, and the inductor will be something times J. They all are in ohms. So after you convert them to impedances, then you can draw it like this in this circuit. So after converting them to impedances, again you can add considering them whether they are in series or parallel. So these two are in parallel, so you can convert it to this. And then these two are in series, you can convert it to 1. And then these two are in parallel, then you can convert it to another one. So you can simplify like you did for resistors. Okay, so I'll give you time for you to do this and let me know when you finish. Here the omega is given. Okay, so you can use that omega 10 omega is 10. L is given. L is this. So for example, if you want to do this, let's do one. If you want to do the inductor, how do we make it to impedance? JWL. Oh, J is the complex J, you have to keep it. So omega is 10 and L is what? L is 3, isn't it? So this will be 30J. Am I right? So this is 30J. You all get 30J for this. So this one is 2, just 2. How about this capacitor here? Negative J times 1 over 3 times, not 3, 10, omega is 10. Yes, so omega is 10 and C is 1.5, isn't it? So that will be what? Negative J over 15, just take it like that. So negative J over 15, isn't it? How about the next one? That will be negative J over 30, I think. Am I right? Did you get all this? Did you get these ones? Okay. Now you can add. Now you are not adding just numbers. You are adding now not the real numbers. You are adding complex numbers. So when they are in parallel to each other, so you can say there are these two are in parallel. No, now you are adding them considering parallel and series connections. So here, when you consider this, how do you add them? 1 over value you need to take, or else you have to. I told you it's easy for you to do in polar form when you have to multiply, because if you need to do this like this, isn't it? So it's like 30J times negative J over 15 divided by 30J plus negative J over 15, like this, isn't it? Is that right? So when you add these together, that will be 30J times negative J over 15 divided by 30J plus negative J over 15. Do you agree with this? They are parallel. So you can, if you want, you can convert it to polar form and do it. Otherwise, this one is not that hard. So when you do this, what is happening? 30 divided by 15 times j squared negative. This is your numerator. Agree or not? Do you get the same for the numerator? You just times that. Is that your numerator? This part will become like this. And the next part will be 30 minus 1 over 15 times j, isn't it? Is that right? So now you can simplify easily. So when you simplify, j will cancel out with the 1j at the top, isn't it? Then you can say negative 30j is equals to 15 times 30 minus 1. Is that right? So if you put these numbers in the calculator, I get 30 divided by, in brackets, 15 times 30 minus 1. So that will be, I get this as 0.07. Do you get the same? Is this right or wrong? When you add these two together, 0.07j negative. Do you have this or not? I'm not sure whether I have done any mistakes. So do you guys get this or not?
Yeah.
No, not the final. Combine with these two. Do you get the same or not? Are you sure? Okay. So we have now combined them together. And if I redraw the circuit, I have now we have combined these two, negative 0.07j, and we have 2 here, and we have negative j over 30 here. Now what can you say about these two? They are in series, so when you add them together, that will become 2 minus 0.07j. Am I right? Now these two are in what? They are in parallel. These two, I mean, this one and this. They are in parallel, so you can consider the parallel combination and do it. Now you can, if you want to, now you can, it's up to you. You can do whatever you want. So that will be negative j over 30 times 2 minus 0.07j divided by, you add these two together. When you add these two together, you have to add them like 2 minus 0.07j minus 1 over 30j. So when, am I right? Is it clear or not? I'm going to delete some of these ones, otherwise I don't have enough space. These two are in series, so we could add them together. These two are in series. Do you agree with that? And when we add them together, we get this. Am I right? So that one and this one are in parallel with each other. Do you agree with that? So now what can we do? We can add them considering the parallel connection. So when they are parallel, they multiply and divide, isn't it? So negative j over 30 times 2 minus 0.07j divided by plus this. Am I right? That's how what you did now in week 1. This is that's why I told week 1 is very important. When you have resistors in parallel, this is how you do. So you do it for the impedance as well. You can find 1 over 30 is what? 1 over 30. Yes, so you have 0.0. So these two are negative. So you can add them together plus another 0.07, which is 0.1. So you have 2 minus 0.1 j at the denominator. Am I right? This part, if you solve it, you get this. Am I right? Very close to 0.1, isn't it? If you round up. And the top part you need to do this way, isn't it? This times this. Am I right? That's how you expand the brackets. So top part will be negative j over 30 times 2. Minus minus will become plus. 1 over 30 times 0.07 j squared. That's how you expand the brackets.
So the impedance on the resistors is ohms, not j ohms.
Resistor, there is no j part. It is, yes, just ohms. Okay. So can you find me the answer, please? So I will do my working outs, but you have to do your working outs and we can double check. So 2 over 30. It should be j squared when you times, isn't it? When you j together. 2 divided by 30 is, so you have 2 minus 0.1 j at the top, and at the bottom we have 0.06 j negative plus, this is also becoming negative. J squared means wherever you have j squared, you can put negative 1 there, isn't it? Am I right? J squared is negative 1. So j squared is negative 1. So 0.07 divided by 30, which is 0.002. So this is what I got. 2 minus 0.1 j divided by negative 0.002 minus 0.06 j. So this is what I got. Did you get this? If I have done anything wrong, you can tell me, okay? So let me know whether you also get this.
Is this part using EV? This one. Is the original test like this?
What do you mean?
This kind of questions.
This kind of questions you can get, yes. Because these are circuits now. This will be a part of your question. We only now trying to combine resistors, combine impedances together. So we have to find voltage. We have to use current division rule, voltage division rule. So we have to do all that later on. Now we are still at the very beginning, but this is electrical now. Before we were just doing the maths part. Now we have integrated that to capacitors, inductors, and resistors. But we have lot more. We have more additional, like, stuff to do. Okay, so we can't keep it like this. You need to convert this to, like, you have to divide it. So when we have to divide it, it is easier to divide with converting to the polar form. So can we convert this to polar form? This one to polar form and this one to polar form. You know how to do them. So can you please convert them to polar form? Top and the bottom separately to polar form. I'll give you time. These are in rectangular form, isn't it? Can you convert them separately, okay? Top and the bottom to polar form. Do you understand everything that we have done so far? We just converted the resistors, inductance and the capacitance to impedance. So when we have everything in impedances, we can add them considering parallel and series connection. So we are still at the end of, like, we haven't finished that part yet. So we have to, this is our final impedance, but we need to further divide, like, to divide these two numbers, complex numbers, it is better to convert them to polar before dividing. So can you please find me the polar form of the numerator and the denominator? They are not equations, they are just a statement. Yes. So top, how do we do this? You do in the same way. So this one is 2 and a negative 0.1. So that is somewhere here, right? This is my numerator part. So what is your R value? R will be 2 squared plus 0.1 squared, square root of this one, isn't it? Theta is what? Theta is a negative value because measuring this way, tan inverse, what is it? 0.1 divided by 2. Okay, so that is your numerator. Denominator, how do we do the denominator? Denominator will be a negative. So this one is 0.002 and this one is 0.06. So it's somewhere here. So our R value will be, I'll take it as R2, 0.002 squared plus 0.06 squared, square root of this, and the theta value will be again negative. Agree? Sorry, it's in the other way around. So you have to tell me when I do something wrong. It's somewhere here, isn't it? And your theta will be all the way here as a positive theta. You can consider it as. So theta 2 is 180 plus tan inverse 0.06 divided by 0.002. Agree? This will be your theta 2, isn't it? Am I right? Is it clear or not? So can you find me these two, please? If you didn't understand what I did, you can ask. No, we haven't done, we haven't finished. We have to go step by step. I can't remember. It's when you get used to this, it is not that hard. It's not like, passing or getting marks. You have to know the theory. Engineering is maths, we have to be good in maths. We are in this building. You trust the engineers who designed it, isn't it? Otherwise, this will, like, when you are driving on the harbor bridge, you trust the engineers who designed it. If you go to a doctor, if he prescribes a wrong prescription, just one person will die. If you wrongly design something, you can search in YouTube. There are so many mistakes the engineers have done. So it's very important for us to be, it's not just passing and getting the certificate. It's a responsible profession. You can be proud of yourself when you do something. You can see it, and many people will be getting advantage of that. Okay, let me know when you finish this. Okay, so let's see what you get. So at the numerator, what you get? R is what? Just 2, yes. And the angle? 3 degrees. Let's take 3, okay? And the denominator is what? 0.6, 0.06 and 88 degrees. Do we all get this? Do we get it or not? So can we proceed with this? Do you get this? Okay. Now how do we divide this in the polar form? You can divide the r's, isn't it? Magnitude you can divide. So you can say this one, when you do it, that will be 2 divided by 0.06. You can put this in the calculator and your angle will be 3 minus 88. Is that right? Isn't it? You can minus the angles and you can divide the numbers. So you get 2 divided by 0.00, 0.06 will be, what's that? 33. Okay, 33.3 and your angle will be negative 85 degrees. Okay, so you have converted this to polar form. If you want to convert this back to rectangular form, you can do that. Am I right? And also if you want to convert, like, you know, now after this, like, you know, if you can do up to here, that then you can do the questions. You need this knowledge to do the real questions. Any question up to here? Did you understand this? You have to practice this, okay? So there are exercises in your tutorial questions, you can do it. Okay, now let's move on. Yes, whatever we found is 89. Where we went wrong? 3 angle is 3 to 30 negative. Which R was wrong? Let me delete this part and see. We also got these ones, am I right? And then we converted the so yeah, if you understood the procedure, that should be, you know, fine for the time being. Otherwise it will take time, but we need to double check our calculations. But the procedure was right. So first we converted all these to impedances, then considering whether they are in parallel or series, we added them, and finally we can have it in the polar form. So we have stopped here. We have, yes, we need to check where we went wrong, and then the angles, you can, after the polar form, you can convert it to rectangular if you want to. So when we do other questions, we will be careful and we'll do the calculations carefully, okay? I already told you. No, I didn't tell you about the. So voltage division rule and the current division rule, you can apply same as that you have done for the resistors. So you can remember, for the voltage division rule, if you have the voltage, total voltage, to find the voltage across Z1, you can times by Z1 and divide by Z1 plus 2. So that's same as your current division rule, sorry, voltage division rule for a resistor. So when you do the current division rule for parallel impedances, when the current comes here, it is splitting, so that can be done. So to find the current going across this one, that will be I times the opposite impedance, Z2 divided by C1 plus C2. If you want to find the, this is your current one. If you want to find the current 2, that will be total current times C1. So you can see the difference here. When you have to find 2, you have to times by the C1 and divide by C1 plus C2. So we need this as well for doing the questions. Okay, so let's do this. And yes, we can stop with this one, and I will do the questions next time. You have to go through this and come next time, okay? Because we are going to do a lot of questions similar to the exam questions. I'm going to do this and finishing it. So, so how do we do this one? They are saying our supply voltage is equals to 5 cos 2t 2t, and they are asking us to find the V1 and V2. Okay, so we can do the voltage division rule here. Am I right? So what do we have? V1 is what? Sorry, V naught. We have to find V naught. Yes, this one. So if I convert them to impedances, this will be 2, and this will be what? This will be J times omega. We know in front of t we have the omega, so 2 times what? 1. And then we have this one, which is negative j over 0.25 times 2, which is negative. So this one will be 2j, negative 2j, and this will be 2j. Am I right? Is that right? So when we can convert this to 3 impedances in series, agree? And this is our Vs, and this will be 2 ohms, and this will be 2j ohms, and this will be negative 2j ohms. Am I right? Have I done anything wrong in the calculations? You got the same, right? Okay, now we need to find the voltage across this one V node. So all 3 are in series with each other, so we can add them together if we want to, but as we need to find the voltage across this, I'm keeping it without touching, but I'm going to add these 2 together and make it to a single impedance. So if I make this to a single impedance, I'll leave the 2j, and when I add these 2 together, that will be 2 minus 2j. Am I right? And this will be our input supply voltage. Now we can divide them. So to find the V naught will be Vs times what? 2j divided by 2 minus 2j, isn't it? Am I right? Is that right? So that will be Vs times j divided by 1 minus j. Agree? Okay, so do we know how to simplify this one? How do we simplify that? 2 will cancel out. We have 2 in everywhere. 2 will cancel out, isn't it? Yes. Sorry. Yes, that's my error. Yes. What should I do? 2 minus 2j plus another 2j, isn't it? Yes. So Vs, and we have only 2j divided by 2, which is easier for us. Too easy now. Yes. So that will be just a j. Just a j. J means what? So we have, I'll delete this part. So V naught is equals to Vs times just j. So V naught is what? That will be 5 and a 0 angle, isn't it? There is no phase for the Vs. Am I right? This one, if you convert it to the polar form, that will be just, and this one is what? 1 and 90 degrees. J means what? Just 0, 0, isn't it? So that will be like this now. That will be like this. Am I right? So that is 90 degrees, and this one will be just 1. Agree or not? If not, you have to tell me. Otherwise, I assume you have 100% understood. Is this one means this? Is that means 0 plus 1j? Is that right? Okay. Do you guys understand? Okay. Okay, so in that case, what we do, these two you can multiply and the angle you can add. Agree? So you can say 5 times 90. So you can write your V naught. V naught will be 5 cos 2t plus 90. Agree? Yes, so your final answer, if you get this question in your final exam, your final answer should be this. What's that? We know that is given. Whatever in front of t will be your omega. Physics, yes. Angular frequency or angular velocity, that is omega. Yes. Same thing. Yes, it's the same thing. Okay, so any question? We'll finish with this. I think there is another class here.